All right, as we continue our unit on modeling data, we're going to look at continuing to talk about correlation coefficients and scatter plots and take a look at the linear models that are suggested by those and use those linear models to interpret the slopes and intercepts of those regression lines and interpret the units. The lesson today is called Getting Schooled as we continue talking about income between men and women and taking a look at that in regards to years of schooling. So in our previous lesson in Getting More Money, Leo and Araceli noticed a difference in men and women's salaries. Araceli thought it was unfair that women were paid less than men. Leo thought that there must be some good reason for the discrepancy. So they decided to dig deeper into the Census Bureau's income data to see if they could understand more about those differences. First, they decided to compare the income of men and women that graduated from high school or equivalent, but did not pursue further schooling. So they created a scatter plot below with the X values representing the average woman's salary for some year, and the Y values representing the average man's salary for the same year. For instance, the year 2011 is represented in the graph by the point 17,887, 30,616. So this point right here. So based on the graph, I'd like you to estimate the correlation coefficient of this regression line, and then also estimate the average income for men in this time period, and talk about how you use the graph to find it, and then the same thing for women. What's the average income and how did you find that? So when you're ready to see what I put down, just restart the video, so pause now. So whatever your guess was, the actual correlation coefficient is 0.6421. You should have guessed that it's positive, and it's not real close together, but it's we can tell that all the points are going up in a positive relation. The average income, what I did was I kind of looked at the values and I said most of them are to the right. So, kind of in the middle of all those values on the line, on a regression line. The men's are about 34,000 and the women are about 19,250. So, pretty big discrepancy there, about $15,000 difference. So Leo and Araceli calculated the linear regression equation to be y equals 2.189x minus 6,731.8. So what does the slope of that line mean about the income of men compared to women? So talk about that using precise units and language. And then I'd like you to take a look at question 5, where Araceli says the whole system's unfair to women. And Leo says, no, wait, let's look at incomes for men and women with bachelor's degrees or more. Maybe it has something to do with levels of education. So with data, we're able to take a look deeper and kind of see if there's any connection. So he wants to do that. And they started with the data for men with bachelor's degrees or more. They found the correlation coefficient for the average salary versus year was R equals negative 0.9145. So predict what the graph would look like. Draw a sample graph. Label your scale on axes and put about 12 points on your graph. So when you're ready to see what I had for questions 4 and 5, you can restart the video. So pause now. Okay, so according to our regression, the slope is 2.189. So since the men are represented by the values of y and women by values of x, that means $2.189 earned by men for every dollar earned by women. So basically the men are earning about $2.19, or about twice as much than the women. Take a look at your prediction. You should have guessed that it's going down and it's pretty close to the line. It's a negative correlation. This is what the scatter plot actually looks like. So how close were you? It looks like it's going down and they're all pretty close to the line. So hopefully you got pretty close to that. But let's look at questions 6 and 7 now. So both Leo and Araceli were surprised at this graph. They calculated the regression line. What does that equation tell us about the income of men with bachelor's degrees from 2000 to 2011? And then he wondered why the y-intercept was, what is that, $1,266,626, yet the graph seems across the y-axis around 72,000. So what are you going to tell Leo? How do we interpret that number? So pause the video and restart it when you're ready. All right, so according to our regression line, it says the salary is declining, it's going down $598 every year. And then number 7, now Leo's wondering why the y-intercept says 1 million, but on the graph it shows something different. That's just according to the way that we have it graphed. So look at the time in years. If we were to go back to, remember, y-intercept is when x is 0. So we have to go back to year 0 in order to figure out what the y-intercept is according to the equation. We just skipped ahead to the 2000s because that's the only salaries that we looked at. A way we could remedy that is we could use 0 for 2000 and 11 for 2011 and call it years since 2000. And if we call it years since 2000, those years represent 2000 would be year 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So typically when we do years, we do it that way, but it's easier to represent on our graphs and makes more sense. So now they turn their attention to women, the data for women with bachelor's degrees or more from 2010 to 2011. Here's the data. I'd like you to create a scatter plot and interpret the correlation coefficient and regression line. Draw the graph, or you can create it on Desmos or your TI graphing calculator. And then report the results of your analysis below. So write down a report. What does this information tell us? So here we saw that the information said salaries are declining for men. What do we gather from women? And then when you're done with that, once you've analyzed the results for women, compare the results for men and women with bachelor's degrees and more over the period from 2000 to 2011 and make a comparison with those based off of the statistics that you have. So pause the video, do that, then restart it when you're ready to see those results. Okay, so I graphed this according to the data as it was listed, where I had my years as my x, income is y, so I used the actual year for my x value. So it corresponded with what we did with the men. And we found that the equation y equals negative 80.8x plus 204,970 with an r value of negative 0.397. So it's a negative correlation, not very strong, but we see the values are dropping as we go down the years. So as we compare the men and the women, we see that the values, for the women are in the 40,000s, whereas the men were 70,000 down through 60,000, so mostly in the 60,000s. So the women were generally a lot less, but the men's salary declining a lot quicker over the years, a lot more over the years, whereas the women's salaries dropped about 80 per year, whereas the men were about 598, about 600 a year. So women weren't as declining as much. In some cases, it seemed like it was going up for a while. So it seems that the women's salaries aren't dropping off as much, but they are much less than the men's salaries, comparing with those with bachelor's degrees or more. So I'd like you to just take some time now before you start working on your assignment to answer these questions. Come up with a case to support either Leo or Araceli. Leo believes that difference in income between men and women is explained by differences in education, basically saying that the more education determines the change in salaries, not just men and women differences. But Araceli believes that there must be other factors such as discrimination. So look at the data that we looked at in this lesson, and also Getting More Money, the lesson before. So look back in your notes. Come up with a case that's going to support either Leo or Araceli. Who do you support and why? I'll take a look at that, and we can talk about that in class. Now, what other data would you find useful in making your case? So what else would you need to know? What would you look for? What other factors would be important in order to determine if there's something more here besides just, are men getting paid more than women? Is it because of education? What else? What other factors would be important to take a look at before we come up with a case, either for Leo or Araceli's side of the case? So work on that, and we'll discuss that and take a look at that in class. Your homework Then in class that you'll work on, you're going to be taking a look at the graphs, finding distances, vertical distances, averages, and finding the sum of those distances. You're just finding the vertical distances away from the line. So counting how far away each point is from the line. And then graph, is this a line of best fit? Talking about correlation coefficients. This is going to help us in our next lesson. And then take a look at these scatter plots, determine whether a linear or exponential model would be best. Then sketch that. And then use the tables to create a scatter plot and talk about the regressions and correlations as well. And then go back to what we talked about with two-way tables and scatter plots. Determine when to use which one. And then talk about, are these functions linear, exponential, or neither? Remember what we talked about with those functions throughout the year. If you have questions with those, we can take care of that in class. We'll see you then.